Okay, so for the forces lesson 3 today, I have two sample problems for you. One's a little easier than the next. So the first one states that a speed skater has a mass of 75 kilograms and is accelerating on the straight part of the track at 4 meters per second squared. We want to know how much force is the skater pushing with. So again, we're going to write out our variables off to the side here. We have that the mass of the skater is 75 kilograms. The acceleration is 4 meters per second squared. So looking for force, you can see that this is the easier problem because hopefully your head is saying to yourself, oh, that's just F equals ma. This funky symbol in front of the F is your sigma. It's the summation of forces when you add all your forces up. In this case, we only have the one speed skater, so we don't have anything to add. So we're going to go ahead and take our 75 kilogram mass and multiply it by our 4 meter per second acceleration, and you'll see that the force with which the speed skater is pushing is actually 300 kilogram meters per second squared, which is actually the same as a Newton. So let's go on here and I'll show you the next problem that I have for you. It's a little bit more intense. It says that we have a car, and the car has a mass of 2,000 kilograms. It's going to hit its brakes and skid to a stop. If the car stops in 6 seconds and the brakes are applying a 10,000 Newton force, how fast was the car going just before the brakes were applied? Well, in this case, it's actually a multi-step problem. We're being told that the mass of the car is 2,000 kilograms. The braking force is 10,000 newtons. And then time is 6 seconds. And we actually want to know an initial velocity. I'm going to call that VI. We know final velocity, it's a hidden zero. It's actually zero because it says that the car comes to a stop. The first thing that we need to do, and what makes this problem a little bit more difficult, is we have to solve for the acceleration. So we're going to go ahead and do F equals ma again and rearrange it to solve for acceleration. So you get force divided by mass. Your force here is 10,000 divided by 2,000. You see that your zeros here cross cancel. I have a Newton divided by a kilogram for my units. Now, if you recall from the previous problem, a Newton is a kilogram times a meter per second squared, which means that the kilogram in the Newton is going to cross cancel with the kilogram in the denominator, and you're left with 10 over 2, or 5, meters per second squared. Unfortunately, though, the problem's not asking us for acceleration. It's asking us for velocity. So I'm going to come down a little bit here to a blank part of the paper, and I'll go ahead and rewrite some things here. We have an acceleration of 5 meters per second squared. We have a final velocity of 0, a time period of 6 seconds, and we want to know how fast were we going initially. Well, when you look at these variables, it looks like a lot, but what it really is acceleration is equal to change in velocity over change in time. Delta V over delta T. This breaks down into final velocity minus initial velocity divided by time. So we can go ahead and rearrange this to solve for velocity. Since our final velocity is 0, that drops out and we're left with V equals AT. So that means initially 5 meters per second squared was our acceleration, times our time of 6 seconds. My seconds cross-cancel one of my seconds in the denominator. So 5 times 6 is 30, and I'm left with the units of meters per second as my initial velocity right before I slammed on my brakes.